Okay. Next, we will have fetching. Right. So we'll say print fetching all balance sheet accounts. Okay, then we will execute and perform basically a fetch all, but we will try a row by row access. So select, this time round, we try a different method. We just want selected columns. We don't want all. So you can always list them where we will change the qualifier. The condition is FR type is BS, balance sheet. And notice that I've used the triple quote here so that when I need to quote a string in SQL, it is easy. So as a matter of personal practice, I always just simply use triple quote. Whether I'm having multi-line or single line, that means maybe even it is just this one-liner, all right, I will still use triple quote just so that, when I need to quote a string in SQL, it's not going to be in conflict. All right, then I will perform a for row in cursor.fetch all. So notice that, well, let me finish first. So name code. So this is the convenient way for within Python, we can easily assign the elements within the tuple to the left-hand side, so long as we list the equivalent number of variables on the left-hand side. So we know that the row has two columns. Therefore, each tuple will have two elements. So it is safe to then just say name, comma, code. And now at line 30, we have a good hold on the actual data item in the database in our variables. So we can do all kinds of things like, I'm just using print, but you can, of course, manipulate all the content within name and code, print out a report, send to printer, email, whatsoever, right? So I'm just doing a very simple print. Whenever you can do a print, you can of course do many other uh, fascinating things, right? So um, the print is just a placeholder for you to use your imagination. Okay, good. So actually, it's not a bad idea to just use a lot of hex signs to demarcate, yeah, the three colored blocks that we have been emphasizing over here. Yeah, okay, so then we get this. Now, maybe with just one quick word over why cursor belongs to the green block and not the yellow block. Okay, I'm not sure if all of you are thinking about that, but maybe some of you are wondering. I thought you always need a cursor anyway, right? Yeah, so the moment you create a connection, you straight away want a cursor because otherwise you cannot issue a command like execute and all that, which is true, which is also bringing to my point here that for cursor, you actually can run multiple times. We're not going to do that here, but you can actually at some point later on say cursor2 equals to con dot cursor, so you can derive multiple cursors, or you're done with this cursor, you want to delete this cursor, and then you create a new cursor again, just to make sure everything is reset to its original condition. So that is possible too, and because of that, cursor's life cycle is really within the green block rather than the yellow block. So it will live within the green block, and then it may get deleted within the green block and then reincarnated again within the green block. So that's why it's logically more matching to put cursor's creation in the green block. All right, we have put in our code and we are ready to run. Okay, so this is not going to create a new database or whatever, and the changes are not visible because we're just reading back. So we will want to see the screen here. Okay, so let's run it and see. Now, this is our starting point. We did get all the PL, the profit and loss. 1, 2, 3 lines. We have 3 lines of PL. Is that right? PL, 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 PL. 4 lines of PL. Okay. Why is that? Because this PL is not an expense subtype, so it was excluded correctly. Yeah, so we get 4 rows. That's nice. So a simple fetch all does the job, and we don't have to iterate, and that's wonderful. We're not trying to say that the least number of lines wins. Rather, it's clear, right? It's very clear, and really having row by row reading is the least of our worries, isn't it? We want the data in, then process the data, make sure our members are served, make sure our customers are happy, and things like that. So yeah, this is nice in that sense of describing what it does and yet being so compact. Next is we say we want to fetch all balance sheet accounts, and indeed all the balance sheet accounts starts with B, so we know we have it. But is that all? Do we have 5 balance sheet accounts? And indeed so, right? So that's good, and it also illustrates how we can proceed row by row. Now, here's one more point I like to point out. Some of you may say, this looks a bit weird. I prefer to do this. All right, so I want all rows, and I would, mentally, I feel that this is clearer to me. Then, I'm basically stepping through a Python list of lists or list of tuples, and that's very clear to me. Some of you may be thinking like that, which is wrong, not wrong in logic. All right, it's not wrong in logic. Yeah, because that's absolutely correct. The only thing is it's not optimized. In terms of efficiency, in terms of efficiency, uh, the this statement here, this third line 30 here, forces fetch all to really get everything. Example, again, I'm trying to magnify the the scale of it. If you have 5 million rows, then line 30 will be stuck there for a while. Okay, so maybe for a minute, for 2 minutes, I don't know. So it keeps reading in, and as it reads in, it needs more and more memory space. So it may need 3 GB of storage. And yeah, most computers, the notebooks and PCs that you and I are using, most of these machines will likely to be very stretched. So you begin to hear a lot of hard disk sounds, and the operating system is trying to balance to get more storage space, borrowing the hard disk to temporarily store and all that stuff. So it's going to make um, really have a huge impact on the efficiency when the rows start to get more. And actually, you don't need 5 million rows to feel that. If you just expand it to 5,000 rows, depending on the machine type and your memory space, you can begin to feel the sluggishness of it all. Then, after that, when it comes to 4 row, and because all rows is a humongous entity now, this 4 row in all rows is going to also be, um, you know, moving rather in a way that is not so optimized. So the best way is actually just try to live with this. If you think it's ugly, then it's ugly. But once you get used to it and you are enjoying the efficient, breezy, very interactive and responsive printout, because the moment you run it straight away, a few rows start to appear, even though future 5,000 rows have yet to come. But it's really nice because you feel the interactivity, right? You feel the first few rows are coming in already. And that kind of feeling, or if you're selling this code, between the two, one competitor will do all rows equals to cursor.fetch all, and you are doing this, your code will be much more appreciated, even if the total runtime is the same. That means by the time we reach 5,000 rows, both would have taken the same time. This method would be more preferred. And besides, when the rows get really large, like 100,000 rows, 1 million rows, um, the effect is not necessarily the same. Yeah, because the all rows equals method will end up taking longer. Yeah. Okay, so just a point to point out here. Okay, good. Let's get back to our classroom. So next, we want to talk about using select, expanding from select. We're going to sort it and learn how to handle huge result sets coming in from select by having limit to the number of rows that we have. Of course, we can also use offset. So limit 3, offset 3 to page through in rows of threes. So we learned that earlier on, but here is how we are going to do it. So what we're going to do is we select the name and call it alias as NM, account code as AC from account. So far, so good. And then we sort it by NM. So we sort it by this descriptive name. Currently, it's probably sorted by FR type. And then within each type, sorted by the account code or something. Yeah, I think so. But it's not by the name. So for human consumption, we like to sort by name, followed by subtype, which is this column here, right? And then limit to only 3 rows. Let's see how that performs. And then we try a new way to do the row by row. We are not using fetch all. We're going to use a new method. So I want to show you this new method called fetch one. Fetch one. So the fetch one just fetches 1 row, and it's guaranteed to be 1 row. And because it's 1 row, it's going to return a tuple, a list of items. So a tuple, and we don't need to have list kind of concept. Just always return 1 record, 1 row, whenever there are still more rows. So you see, we need to check because the return row could be that fetch 1 reads and there's actually no more. Right? So if we have 3 rows, the first time is okay, second time okay, third time okay, fourth time, nothing else. So the fetch one will actually make row none, a none value. Fortunately, it doesn't create an exception. So that's good. But we need to check because if row is none and we still continue printing, we'll see very strange results in our printout, on our screen, and so on. So definitely we do this if row is none, then we break out of the while true forever loop. So we need a while true here because up front, we have no idea how many rows are there. You can say that, oh, isn't it limited to 3? So we should have 3. What if you don't have any? What if there was only 1 row being returned? Because you don't know the content of the database, right? And that's precisely why you describe by, I want these to order by this, limit to 3. So what we want is this setup, right? So while forever, while true means for while forever. While forever, fetch the row. If the row is none, break out. Otherwise, continue to process because there's content, there's meat in this row here. So process it. Okay, so let's try this out.